Alright, here we go. Lesson 27, Rationalizing Denominators with Square Roots. Okay, I'm going to go quickly here for the sake of time. So, I taught you about this word rationalize denominators. Rationalize means, in math, it means making the fraction, or making the fraction actually a legitimate fraction. But I like to liken it to, you're not done with the problem, there's some loose ends you have to tie up, okay? So, we already talked about rationalizing denominators when we talked about fractional exponents. Look up here, 1 over x to the 1/2. What's wrong with 1 over x to the 1/2? The 1/2 is a fraction, so you would have to multiply the denominator by 1/2 to make it the next whole number, and the numerator to rationalize it, so the numerator becomes 1 times x to the 1/2, which is x to the 1/2. Denominator becomes x to the 1/2 times x to the 1/2, which is x to the first, or just x, okay? We did that, and then 2 weeks ago we talked about this. Let's say we had 3 over I, okay? We don't like imaginary numbers in our denominator, so the way we get rid of them is we multiply by the conjugate, okay? Conjugate, remember that word? So the conjugate of I, in this case, would be negative I. So we multiply by negative I. Okay? So 3 times, the numerator becomes 3 times negative I is negative 3I. Denominator becomes I times negative I, which is negative I squared. And we know that I squared is going to be negative 1, so negative 1 times negative sign is positive 1. Numerator is negative 3I. So negative 3I times 1 is negative 3I. Okay? So that's the simplified version. So today we're going to talk about what happens when you have a square root sign in the denominator. Okay? We don't like that in math. So how do we get rid of it? Talk about it. So here are the steps. If you're on the video, please write them down. If you're in class, here we go. Numbers 1 and 2. Number 1, 3 rad 4 over rad 6. So let's say that number 1, this is the answer you got from a long problem. You got to this part now. We don't like rad 6 in our denominator, so how do we get rid of a rad 6? Since it's a single radical, it's a monomial, we would multiply it by itself, so rad 6, we multiply it by itself, so rad 6 times rad 6, numerator times rad 6. Okay? So in our numerator, we got 3 rad 4 times rad 6. We multiply the radicals together. 4 times 6 is 24. So we keep that in the radical sign. The 3 we leave on the outside. So it's 3 rad 24. Denominator, rad 6 times rad 6 is like saying rad 36, which is just 6. Yep. Okay. Rad 24 now is the same thing as saying 4 times 6. Square root of 4 is 2, so it's going to be 3 times. I'm going to take out a 2. All over 6. 3 times 2 is 6. So it's going to be 6 rad 6 over 6. 6's can cancel out. So it's just going to be rad 6. That's your answer. Okay? That's on number 1. Okay? That's a lot of extra work, right? Some things you could skip steps in, okay? I showed you like the stepping stones of this one. Okay? That's number 1. For the sake of time, I'm sorry we don't have it because we had that good discussion. Number 2. We have negative 2 minus 2 rad 5 over 4 minus rad 2. So in the denominator here we have a binomial with a radical. So the way you get rid of it is you multiply by the conjugate. The conjugate's super easy. You just take 4 and then you change the sign to the opposite, which is in this case is going to be plus rad 2. So we got 4 plus rad 2 here. Okay. So we got to multiply across negative 2. Oh, this is a binomial, by the way. Negative 2 times 4 is negative 8. Negative 2 times rad 2 is going to be negative 2 rad 2. Okay. Continuing on here. Then we have negative 2 rad 5 times 4 is negative 8 rad 5. And then we have negative 2 rad 5 times rad 2 is going to be negative 2 rad 10. Oh, negative 2 rad 10. Denominator is a difference of squares problem. Whenever you multiply by the conjugate, it's a difference of squares problem. So 4 times 4 is 16. And then rad 2 times rad 2 is just 2. Put a minus sign in the middle. That's all you have to do there. When we simplify the numerator, the only thing I could simplify in the numerator is really nothing. I can't take anything out. Rad 2, rad 5, and rad 10 are pretty much simplified. So I'm just going to copy it down here. You got negative 8, minus 2, rad 2, minus 8 rad 5, minus 2 rad 10. Okay, 16 minus 2 is 14. Then I'm looking at all my terms here. What goes into negative 8, negative 2, negative 8, and negative 2, and 14 at the same time? Well, the only thing that goes in there is 2. I could put a 2 into all of these terms, okay? All of these terms I could put in a 2, or take out a 2. So this becomes negative 4 minus rad 2 minus 4 rad 5 minus rad 10. Denominator becomes just 7. Nothing else I could really do, so that's your answer. And you might say, this is simpler. No, this is not simpler. The denominator, though, is not a radical sign anymore. It's just a number. That's why it's called rational expression ratio, which means fraction. Okay. Here, write this down as I take the... Write this down. Okay, continuing on number 3. Since we only have 4 short minutes, actually it's 3 minutes and 45 seconds. So we multiply the denominator, or denominator is a radical sign. It's by itself. Since that's the case, you multiply the denominator by itself. So it's going to be 2 rad 2. Numerator is going to be 2 rad 2. Okay? If it was a binomial, you multiply by the conjugate. So we multiply across. 5 times rad 2 is rad 10. And then the coefficients is 1 times 2, which is 2. Denominator, 2 times 2 is 4. Rad 2 times rad 2 is just 2. 4 times 2 is 8. Simplify, the only number that goes into both 2 and 4 is 2. So it's going to be rad 10 over 4. Is that right? Yeah, that's right. Okay, I can't simplify rad 10. Alright, and I'm going to conclude the lesson here, since we only have 3 minutes left.